these laws of indices then. The first law of indices is saying that if the base is the same, and this is the key, all these laws of indices only work if the base number is the same. So if I look at this number like x to the a, then what we do is we call this number the base number like 3, and this is the power, or the index, hence the laws of indices, the power to which I've raised that base. For example, 3 to the power 4. And that means 3 times 3 times 3 times 3, as I think we all know. 3 to the power 4, okay? So that's the basic information about these things. We talk about the base and the power. In this first law of indices, and it's the same for all of them, the base must be the same or it doesn't work. So whatever number that is, it's got to be the same here. An example might be 3 to the power 4 multiplied by 3 to the power 2, 3 squared, would be 3 to the power 6. I just add the powers together. That's what the laws of indices are saying. But if we think about it, actually, that makes perfect sense, because 3 to the power 4 means 3 multiplied by itself 4 times, and 3 squared means 3 multiplied by itself twice. So you can see we've got 6 lots of 3 there, which is 3 to the power 6. So that's where that comes from. And it's obvious now, isn't it, that it's only going to work if they're the same number. Okay? What about this? 4 to the power a half multiplied by 4 to the power a third. Using the laws of indices, what's the answer? What's a half plus a third? What have we got to do to be able to do that? Change that, right. What would a common denominator be? Right, so that's like 4 to the 3/6, because a half is 3/6, multiplied by 4 to the power 2/6, which is 5/6. Right, so it works with fractions. And we'll come on to the fractions when we look at that law of indices with the power, with the roots in, if you remember. So we'll need that for that. What about this? 4 to the power 8 multiply 4 to the power minus 5. What would that be? 3. So the same rule applies whether or not they're whole numbers, negative numbers, fractions. Okay? You just add the powers. So the second law, x to the a divided by x to the b, again, so long as the base is the same, what do I do with the powers from the second law of indices? Minus them. So it's the same as x to the a minus b. For example, 3 to the power 5 divided by 3 to the power 2 would be 3 to the power 3. Yeah. And we could actually show it, because if I think about what 3 to the power 5 looks like, it's 3 times by itself 5 times, one more, over 3 times 3. And we can do some cancelling top and bottom. 3's goes into 3 once, top and bottom. That 3 at the bottom cancels with another of the 3's at the top. So I can actually cancel out 2 3's at the top with 2 3's at the bottom, leaving just 1 at the bottom and 3 3's at the top, which is 3 cubed. So that shows it. There's some cancelling going on, which is why you subtract powers. I could do a similar thing with fractions, but I'd subtract instead of adding. And I could do a similar thing with negative numbers. What about 4 to the power 2 divided by 4 to the power minus 3. What would that be? No. No. Top one, subtract the bottom one. 2 minus 3. Right, I have to add them. 4 to the power 5, okay? Minus gives us a plus. So we might well come across a problem like that. So it doesn't matter whether or not we're talking about fractions or whole numbers or negative numbers. One divided by the other, you subtract the bottom number from the top number. So for the third one, x to the a raised to a power b, x to the a times b. For example, 3 squared cubed would be 3 to the 6. 2 times 3 is 6. And if we think about why this works, what's 3 squared? It's 3 times 3. Cubed means I'm multiplying that lot by itself 3 times. That's what that's saying. And that's 2, 4, 6, 3 to the 6. So you can see how it works. Okay? What would 5 cubed to the power half be? 1.5 or 3 over 2. We write it as 3 over 2 generally, but 1.5 would be fine. We tend to avoid mixed numbers. So 5 to the 3 over 2. 3 times a half, 3 over 2, or 1.5. So you could write 5 to the 1.5. But because of what we're going to do in a minute, you'd possibly leave it like that. Okay? But either answer would do. Next law of indices, 1 over x to the a. We write it as, what's the rule say? X to the negative a. This is saying the inverse, Josh, the inverse of a number, x to the a. The inverse of x to the a is 1 over x to the a. The inverse, when we talk about the inverse, and you've got an inverse button on your calculator, 1 over. Inverse 1 over of a number is given by 1 over that number. That's what the inverse means. The 1 over it, 1 divided by it, the inverse. Find the inverse of 3, 1 over 3. So what's the inverse of the number 4 cubed? 1 over 4 cubed, that's how I'd write it. What's the inverse? 1 over it. How can I write that as a power? It's 4 to the power minus 3. The inverse is written as a negative power. We can show why it works by looking at the second law of indices. If I've got something like 3 squared over 3 to the power 4, for example, let's use just 3 over 3 to the power 4. What's the power of 3, by the way, that I've not written here? 1, right, it's a 1. If there's no number there, it's a 1. So that would be, using the second law of indices, I'd say 1 take away 4 is negative 3. Okay? But writing down what this actually means, it's 3 over 3 times 3 times 3 times 3. And if we look at it, the 3 on the top cancels with one of the 3's on the bottom, leaving 1 over 3 cubed. So 1 over 3 cubed is the same as 3 to the minus 3. And negative power is the same as the inverse. And that's sort of proving it. So this fifth rule is probably the most awkward to see what's going on. But as easy as the others to remember, just to remember what the rule is. So how can I rewrite the bth root of x to the a, as this is saying? I'd write it as x to the power a over b. Now, you've got two numbers here. For example, if we look at this one, the cube root of x squared, for example, would be written as x to the 2 over 3. There's some confusion about which number goes on top, which number goes on the bottom. And the way I remember it is, if you think about it, the root, because this is the root, the cube root, so the roots go under the ground. So the root goes underneath in the fraction. Okay? If you remember that, you won't get it the wrong way around. So where does this rule come from? If I take a number like, say, 9, the square root of 9, answer? 3. Multiplied by the square root of 9 is 9. The square root of a number is a number. If I multiply by itself, I get 9. So the square root of 9 multiplied by the square root of 9 gives 9, doesn't it? The square root of 5 is not a number that's easy to say. We could do it on the calculator. The 2 squared is 4, so it'll be 2 point something. Okay? The square root of 5, though, multiplied by the square root of 5, we do know the answer to that. It's 5. Okay? Because the definition of a square root is a number which, when we multiply it by itself, gives that number. X, the square root of x, multiplied by the square root of x gives x. Right, good. Okay? Whatever the number is, it doesn't matter. I multiply it by itself. Okay? I get the number x. Now, x to the power half multiplied by x to the power half from the first law of indices is x to the power 1, or just x, Taylor, yeah? A half plus a half, 1. We don't normally bother to write the 1. Look at this. That's the same as that. So this must be same as that. Okay? The square root of a number, and what I've not put in here is that x to the power 1 is, that's just x to the power 1, and the square root, we don't normally write the square root, but there's a 2 there, so the square root of x to the 1 is written as x to the 1 over 2. And that's the argument, that's the proof. Okay? And the same thing would apply for the cube root. What's the cube root of 27? No. The number which I times it by itself twice gives 27. 3 3s are 9 times 3, 27. It's 3. Okay? Times it by itself again and again. Answer. So, the cube root of 27 multiplied by the cube root of 7 multiplied by the cube root of 7 is 27. 3 times 3 times 3 is 27. The same argument is going to apply. The cube root of x times the cube root of x times the cube root of x is x. Same argument as we've just been doing for the square root. So if I think of a fraction, what fraction adds up 3 of them to get 1? A third. A third plus a third plus a third is 1. So the cube root is a third, and that's where that root comes from. The root is always the number underneath in the fraction. The last rule of indices says that anything to the power 0 is 1. What's pi to the power 0? 1. Anything to the power 0 is 1. And if you think about the second law of indices, you can have a go at trying to prove why that is. Okay, and I'll leave you to do that.